afternoon, and thank you for joining us for this afternoon's Digital Futures session. This afternoon we're going to be looking at Digital Futures Coding Unit, and we are joined by Niall from Tablet Academy Scotland, Jacqueline, who you can see here beside me, and in the background we also have Lara from Microsoft too, and I'll introduce Jacqueline properly just shortly. So this afternoon, we're going to be looking at the coding unit of Digital Futures. This is a unit you can pick up and use within your classroom. It's designed specifically for third and fourth level, so secondary. However, it can be adapted and used in primary as well. You know your learners, you know their abilities, and the units themselves are really flexible and can be used in a range of ways. So the modules of Digital Future are 5 in total. Last night we ran our Discover the Tech Industry, where we had 2 amazing interns from Microsoft who came along and spoke about their current role. And tonight, as I've mentioned, we have Jacqueline Russell, and she is from Microsoft MakeCode program. She's their product manager. So we're going to look at how the unit here can be used to advise and inspire your young people in the world of coding and look at routes that they can take into potential career paths. We'll then look at the 3 areas that the coding unit covers. If you've not seen the units before, the link is at the bottom. If you search for Digital Future Program Microsoft, it will come up for you. So the unit that we're looking at today is got 3 areas: explore, practice, and apply. All of the course materials are aligned to the curriculum. They have been identified to be with technologies and literacy for this unit, the E's and O's, and we're particularly looking at the computing science area of the curriculum. So how it can be used to design, develop programs, how young people can put together an algorithm, problem solve, use meta skills in everyday practice within your classroom. We'll also look at how they can perhaps join some of the unit work from other areas, for example, the accessibility and inclusion learning that may have been taking place if you did Unit 1, the Discover Tech Industry, and how that can be incorporated in this coding unit. So we're going to be able to, hopefully by the end of this unit, let you see how you can use it to cover how they can choose different reasons and why they might code, careers that they're going to be undertaking potentially, misconceptions, and there's an amazing quiz that we're going to look at for that. Coding resources and computing science packages that you can access, challenges that are available to you free of charge, and what work you can do through this unit. So with that, I'm going to stop sharing my screen and I'm going to hand over to Jacqueline, and I'd like to introduce you to Jacqueline Russell, Product Manager for Microsoft MakeCode.
Thanks so much, Jen. Hello, everyone, and thank you for having me here as part of this amazing Explore the Digital Future program. Jen and Laura asked me to come and speak with you all about computing education and share a little bit of insight into sort of the technology industry and applications of computing skills in the real world. So I thought I would cover a few things. One is just give you a little bit of an introduction into who I am and what I do at Microsoft. Then I'll talk a little bit about sort of my personal journey or path into computing and technology. And then I'll cover off on, why is it so important to be teaching young people about computers and technology? And then as part of that discussion, I'll talk a little bit about physical computing, which is near and dear to my heart. And then kind of give you a little bit of an overview of MakeCode, which is the product that I work on here at Microsoft. And then I also want to give space for Q&A. So if you do have questions as I go through any of this content or material, or just curious about, what I do or computing jobs in general, please go ahead and pop those into the chat and we can discuss those at the end, or you might be able to come off mute and we can also ask questions at the very end. All right. So as Jen mentioned, I'm a product manager at Microsoft. I work on an educational product called Microsoft MateCode. It's an online learning environment for primary and secondary school students to learn to code in a hopefully fun and engaging way. So this is a photo of part of our team at the office at a daily meeting we have called Stand Up. I'll just circle, that's me in the back there. And for this meeting, you can see that we don't all actually stand up, but we do kind of all huddle together around, every day we do this and kind of go around and share any updates, what people are working on, and discuss decisions that we need to make as a team. So on our team, there are 3 different roles. So there's product managers like myself. There are software engineers who do all the coding and build the product features. And then there are designers who come up with all of the designs. Now, the job of a product manager is to do a lot of what we call customer development. And this consists of user testing, interviews with customers, market research to identify opportunities and trends, and then bringing back all of these insights to the team to sort of determine our product roadmap and also manage our release schedule. We also do a lot of training and documentation on how to actually use the product for customers. We also do a lot of data analysis and reporting on how the product is actually being used, and kind of are just general stewards of the product. And again, we work very, very closely with both the design and engineering teams to come up with new product features and capabilities. So let's back up a little bit, and I thought I would spend some time kind of sharing with you all my journey into computing. And this started when I was 11 years old. We had some neighbors who, Mr. Simon, who would come over, every afternoon or so for tea with my parents. And one day he was complaining that he couldn't understand this newfangled software called Excel, Microsoft Excel. And he was trying to do his taxes and calculate his household finances using this program, but he was having so many issues. And so my mother volunteered me to help Mr. Simon. And so one day after school, I went over to his house and kind of took a look at his spreadsheet and tried to help him with calculating his taxes. And so just kind of helped him format the columns and rows, did a few very lightweight formulas for him. But he was so impressed with this that ever since then, he started calling me the tech whiz kid, right? So it would be like, oh, there goes the tech whiz kid. And for me, that was kind of a turning point, because even though I, up until then, had not considered myself, exceptional with computer skills or, technology, because of that sort of perception that, oh, well, maybe I am pretty good at technology, that became a reality for me. And so I turned into the go-to kid that people would go to when they had problems with their computers or couldn't figure out their modem connections, or even needed help programming their television remotes, right? And so this idea of, at this young age, this perception that, yes, you are good at, technology is so important for students. And so that was a great first kind of introduction into technology and computing for me. And it really kind of helped build my self-confidence that, I could do things with technology and computing. Unfortunately, neither my middle school nor my high school had any computing classes or any technology classes in general. And so my next kind of brush with computing came at the university level. Now, I had gone to university thinking I would be a math major. I had a really great math teacher in high school who really influenced me, and I loved math. But, and at the time, the math department was co-located in the same building as the computer science department. And I distinctly remember freshman year in college, sitting in a, quite boring math class where we were, proving theorems, doing these very long, complicated theorem proofs. And just looking out through the window of the door of the classroom into the other classroom across the hall and seeing these kids, wiring up these things, and there were lights and like buzzers going, and thinking, what are they doing? That looks like so much fun. And so the next semester I signed up for that class. It ended up being a intro to CS class where students were, breadboarding their own very basic calculators with circuits and LED lights. And I just kind of fell in love with the idea of building stuff with technology. And so after that class, it just kind of hooked me. And I went on and majored in computer science and was also a volunteer at the computer lab and a teaching assistant, and really kind of gravitated to those classes. And after university, I got a job as a software developer and also an IT admin, and then came to Microsoft, where I really kind of came to the insight that I loved jobs where I could use computing in a very creative way. So I've been working at Microsoft for the past 17 years now, and I've had many different jobs along that way. But like I said, the jobs that I really love the most are ones where I was able to use technology in very creative ways, and also in teaching and learning. And so the job that I currently have now is one of my favorite jobs, because I get this photo is of me at a computer science fair with some students demonstrating one of the microbit air guitars. So things like this is what I really love to do. All right, so let's talk a little bit about why we think it's important to teach computer science. So I think we can all agree that the purpose of education is to prepare students for ongoing education, for their careers, and for citizenship. And I love this quote from Malcolm X here, where he says, "Education is the passport to the future. Tomorrow belongs to those who prepare for it today." And that's true even more so today, probably. We live in a time of unprecedented technology change, right? With hugely rapidly evolving economy and labor market. And so these are some of the job listings that I pulled online for the year 2030. These have been predicted. And some of these exist today, actually. But things like this augmented reality journey builder, so designing virtual experiences for retail and whatnot, and games. AI healthcare technician, this one actually exists today. So using artificial intelligence to diagnose and treat patients. Smart city analyst, so analyzing data from IoT sensors, and transport controller, for the brave new world of automated vehicles and drones. And all of these jobs require a deep level of comfort and understanding of technology. These aren't specialized computer science jobs. These are going to be normal, everyday jobs. And this reality is very close, right? Closer than we think. So when Microsoft thinks about education, we think about how we can best help schools and educators prepare students for this future. And not just by using technology to teach and learn, but by teaching and learning about technology. So in just a few stats, I'm not going to belabor this point, but we know that there's huge growth and demand for technology skills in the economy. We see computing skills being required in more and more professions, across the board. And just within software development, there's been a 22% projected growth in this field. So that's 3 times more than the average job market growth rate. And apologies, these stats are actually all US based, but I'm sure UK Scotland numbers are very similar. And you can see that, despite this demand, at the same time, there's just not enough skilled students or an equitable pipeline of talent, right? And we know that technology creators are going to be shaping all of our futures. And so we need to make sure that those creators represent all of us. All right, so we do know that computer science at the primary and secondary level is critical to prepare students to be successful in this digital world and to create that diverse pipeline. But I think we do know also that computer science has had some challenges in this space. One of the big challenges is, of course, educator capacity. There's just not enough teachers with these skills to teach these subjects. And that's why you all are in this program. And the second challenge, I think, is also equitable access and engagement, right? We see girls and other underrepresented minority student populations opting out of these types of classes. And so our challenge is to make learning about technology fun, relevant, and exciting for every student. And so that's why we're trying to shift more of this sort of computing education from these computer lab type environments into more of the core classrooms and the core curriculum in schools. So more like spaces like this. And this is what we call sort of hands-on computing. So where we really think about the learner as the center of the learning activity, not the technology. And the technology is really kind of more of a building material, right? It's not an endpoint where you have a student staring at a screen, but really kind of a classroom resource like construction paper or popsicle sticks, right? And so our approach to computer science is really meant to be hands-on, playful, and personal. And it's something that we believe every student should be exposed to. And we use something called physical computing as an inclusive approach to computing education. So physical computing, of course, is how I got into computers at the university level. So again, it's a little bit near and dear to my heart, but we also do know that other approaches like games, game-based learning is also very, very engaging for students. But I thought I would spend a little bit of time here just talking about physical computing. So just in terms of a definition, when we talk about physical computing, we mean essentially any kind of physical device that can be programmed. And we see a lot of benefits to this approach. So first of all, it gives a more holistic view of CS education. So computers and computer science isn't just about learning to code. That's a big part of it for sure. But computer systems are made up of hardware, software, data, networking, right? It's important to be able to teach all aspects. Creativity and self-expression. I talked a little bit about this before and about that being sort of one of the grounding principles of my career. Technology is extremely creative and physical computing even more so. especially when you bring in the crafting and the making aspects. Makes it so much more engaging for a broad range of students. In a lot of these projects, the coding isn't necessarily done for coding's sake. It's done in service of creating a very personally meaningful project for the student. Learning by doing, trial and error is how kids learn when you do physical computing. Either the light lights up or it doesn't, and you got to figure out why not, right? And then experiential learning. A lot of research to back up the value of kinesthetic and experiential learning. Students learn with their hands and their bodies just as much as they do, sitting at a desk and reading or writing. Industry IoT trends, certainly the Internet of Things is here to stay. And students are learning great skills that will help prepare them for this, new world of intelligent edge devices. And lastly, I would just say there is this magical moment that happens when, a student makes a light flash or a buzzer buzz, through code. So this combination of the digital world and the physical world, I think really showcases the true magic of technology. And we're definitely seeing evidence that this approach is working. So this is just some stats from the BBC back in 2017, I believe. They did this study where they did pre and post surveys of students, and they distributed about 1 million microbits across the UK and found that there was a 70% increase in interest among students, among girls, especially, to continue studying computer science after having been exposed to the microbit. So, encouraging results. If you are interested in learning more about the benefits of physical computing, there's a lot of research available, both on the MakeCode site as well as the microbit.org site. All right, I'm just checking chat to see if there's any questions here. Yeah, okay. So let me switch gears really quick and talk a little bit about MakeCode, which is the product that I work on. So again, we got a lot of our roots of MakeCode around this physical computing aspect. And so that even shows up in our name, MakeCode. We really believe in the value of constructionism learning and making things as well as coding. So combining that magic of making and the maker mindset with the power of code. Our mission is to inspire the next generation of technology creators. And as I mentioned before, we really do this by trying to make an approachable experience for students with a broad range of interests and skill levels. You can find our product online if you go to makecode.com. You'll see we've got a few different code editors available. Certainly for the microbit, which is what I talked about before, that was our very first code editor. But we also support other microcontroller devices, some robotics, and then games and game-based learning, as I mentioned before. This is just an example of some fun student projects that we do, and certainly that have been posted on Twitter. Things like a magic wand, those air guitars that I talked about before, laser tag, and these wrist cuffs, this pedometer wrist cuffs, as well as like wallets that calculate how much money you have, things like that. When we first set out to build MakeCode, we had some core product principles we wanted to follow. Again, our mission was around this idea of hands-on computing. We also wanted to make sure that the product just worked for every teacher and every classroom. And so MakeCode is free, it's online, there's nothing to download and install, so it works across platforms and devices and browsers. We wanted to really focus on this idea of inclusive computing education. So making sure that whatever we offer are these, physical or immersive experiences. And then we also wanted to make sure that MakeCode had a progression path to real world skills. So we offer both the drag and drop block-based programming, as well as JavaScript and Python sort of real world text editing programming. And then lastly, we really see ourselves as a platform. So we're open source and we work with many different partners to support them and extend this coding environment to others. All right, well, that's all I had prepared to talk about, but I'm happy to take any questions that you may have about my work, what I do at Microsoft, how computing skills, help in the real world. Any question you may have. Anything about MakeCode?
So I can't see in the chat at the moment. One thing I was going to ask you, so do you think someone identifying you as that sort of tech guru when you were younger gave you that confidence? Gave you that confidence when you started your maths course and you saw this amazing computing work going on across the way? Do you think that gave you an inner confidence to try that, or do you think that was already built in?
No, absolutely. That early experience really kind of helped me with my own self-perception of, who I was and my capabilities. And I will say, the computing courses back then at university, I was the only girl, and for example, in that first class. And so very easy to be intimidated and think that you don't belong, or that, this content is above you, or you're not a techie, right? And so I think it was super important having that very early on first exposure that, I was good at computers and I could figure things out, right?
Yeah, absolutely. And do you think that the makeup of your team, so we saw you at the stand-up in the morning, everyone will be coming with their own sort of journeys, that combined sort of background interest, previous experience combines to make a stronger team?
Oh, absolutely. Yeah. And, I think the diversity of thought is so important, and being open to each other. And, a lot of times at those stand-up meetings, we will have very strong opinions that, are sometimes conflicting, or, don't agree. It all comes from this shared goal of building the best product for our customers, but sometimes we disagree on how that works. But every single person in the team is very respectful of each other's perceptions of, the diversity of backgrounds and thought. And, at the end, we come out with a final product or a final decision that is better for all of the diverse, different ideas and thoughts that are brought to the table.
Absolutely, I couldn't agree more. I've got a question as if I was going to be bringing my class. So if we were to come and visit you, what would you think would be the most surprising element of visiting you at Microsoft with your team? If I was to bring my learners along, what do you think they would find the most?
Yeah, that's a really good question. I think what might be surprising is how much fun we have at work. I think a lot of times, kids imagine adults going into these, very boring office buildings with cubicles and just sitting down at their computers and like typing on a keyboard and kind of just, working all day, right? But that's not the reality, right? We work in a great space with, we've got video arcade machines and, all sorts of physical computing maker spaces going on. And, most of the time we're all working together or discussing things together. It's very open, collaborative space. So I think that might be surprising in terms of the perception that many students have about, what it means to be a programmer or work in, the tech industry.
Absolutely. And my last question that I had that I thought some people might also be thinking is two-part. What would you say is your favorite Make Code project that people could maybe get started with? And also, what is one of the most innovative ones that either you or a member or somebody on social media has shared with you using Make Code?
Yeah, that's a really good question. So I will say that one of the projects that's currently top of mind for me is one I created just last week. So our team had a hackathon. We do these quarterly hackathons where we set aside just a couple of days and just work on a fun project. And so the project I came up with during that hackathon was a arcade shoebox controller. So, and I can paste it in the chat here for anyone who's interested. It may not be like a first project, I would say, for using Make Code, but it's one that's kind of top of mind for me just because I just worked on it last week and I had a lot of fun. And it's very surprisingly easy to do. So you just need to buy the right equipment, but you just need a shoebox and a joystick and buttons and hours of fun. My kids loved these. So that's a good one. That's a good project that kind of just comes top of mind for me. But one of the great projects that I use a lot in workshops is a microbit radio project. So I'm not sure if you all are using microbits in your curriculum, but they're amazing devices and very flexible. You can start with low ceiling and go very deep very quickly. Sorry, low floors, high ceilings is what I meant to say. But there's a radio group project that I do a lot. It's kind of like an icebreaker project where I have people pick a choice. So I give them a choice of, like, for example, where's your favorite vacation spot? Is it a beach? Is it, camping in the mountains? Is it, going to a city you haven't explored before? And so I give people a choice of, probably 1 to 5 different choices as sort of, and then they program that choice as a radio group setting. And then they program their names as part of that group to send their names to others. And then I have people just kind of wander around the room calling out names that they see in their group. And then each group kind of gets together and forms their tribe of, like, these are the beachgoers, or these are the campers, or the outdoorsy people, right? And so it's a nice kind of little icebreaker activity when you're doing, large groups of workshops. And the power of the radio is really wonderful. And so I love to use the radio on the microbit.
That's super. Thank you so much. I'm sure that's a really great idea as well for some of our practitioners who might be watching along or watching our recording later to get an idea for something they could use in classroom. So thank you.
Yeah.
Jacqueline, thank you so much for your presentation. That's been absolutely super. Thank you very, very much. We'll keep an eye on the chat, and if any other questions come in, we'll definitely give them over to you. So thank you. Okay, so with that, I'm going to share my screen and hopefully you can all see my screen there. So following on from that amazing input from Jacqueline, I thought that we would just have a really, really quick look through the resources that you can explore at your leisure through Digital Futures. If you Google, if you search for Digital Futures Microsoft, it'll come up. And here we can see we've got the resources. Part of the resources is the curriculum document I was referring to earlier. So you can see it clearly identifies where it links to literacy and health and well-being, but also where we really clearly link to 1415 in the computing science. And although it's identified at 3rd and 4th level, like I mentioned, this could be used at an earlier level too. So The project itself is broken into explore, practice and apply. 3 really easy units, each one taking about an hour. So if you are secondary, sort of 1 period per session. And then you can obviously then use the apply section much further than that to apply and use lots of different resources, including MakeCode that Jacqueline just spoke about there, micro bits that your department may have, and tie them in. So the Explorer code allows you to have 4 different areas, big questions, and then looking at the work that coders do, that again Jacqueline just spoke about, the benefits of coding to society, and that's where we're going to look at a really super quiz that's incorporated into it, and diversity. So here you can see there's lots of prompts for you so that you can really pick this up and use it instantly. Why would we learn how to code? Who knows how to code? What do you know how to code? Where is it? Go on an environment walk around your school estate. Go on an environment walk around your school's community. Where are you seeing computing being applied? What difference could you do what would you make a change, and how would we program that change if we were going to implement it? Where are also people maybe using data to impact? So looking at that big data, and that's a unit that we've got coming up, but using that data to implement change by coding things differently. So we have a whole range of questions looking at careers that can be there. And again, there's prompts, but again, making that link into the diversity of the workforce, the diversity of careers that are available to people. So not just thinking overtly of programmers, but thinking how that, just again, as we spoke about earlier, how that's used in careers more discreetly, perhaps, where people wouldn't naturally think of it, and the creativity that underpins a lot of computing science, especially around sort of the design of products, buildings that may incorporate code for their use. And robotics has a huge range of creativity in it as well. So the quiz that I mentioned, part of our project, this project gives you these explore code, and there's an educator pack and the lesson slides. The lesson slides are set up with these big questions, and then you're given the answers in the next slide. So again, it talks about, it's based on UK stats, so 17% tech jobs are held by women. It talks about salary scales. It talks about what is the difference between coder and programmer, gender diversity within the workforce, what kind of roles are involved in it. So there's a whole set of questions to prompt it and prompt those discussions, making learners more aware of what actually the world of computing science might look like and what it's like to be a coder. Also thinking about, again, as Jacqueline said, jobs that are emerging, jobs that didn't exist or don't currently exist, but also jobs that maybe we're not aware of. That's one of the things in the last 3 years, things that are maybe thought of as jobs of the future are actually already taking place, just maybe not in such a prominent way. So this is a really nice way to introduce those discussions, link out with different groups such as STEM Ambassadors Organisation. So maybe having focus on a particular industry and looking at how they have coding and computing science being used and in ways in which you might not have thought. So again, looking at coding and how it might be used within the arts industry. Digital art is a huge industry, and images sell for huge amounts of money, as do people programming resources to capture things and to scan in things, and what the programming behind that, how they would program things like that. So there's lots of ways we could apply coding, and this is a really nice way to start thinking about that diversity, transferable skills and meta skills. And STEM ambassadors, I would definitely recommend linking out with your further higher education, colleges, universities, and DYW leads as well. So at the end of the educator pack, you'll see there's posters involved, there's lots more questions. There's then suggestions for additional links out. So once you've had all these conversations, where do you go? So some of the resources you'll probably be already familiar with, code.org, and because this is aimed at secondary, you might want to start looking at some of the resources if you've not already seen them around AI. Some resources do need you to sign in, but most of them don't. So there's a whole range in there, and then there's a whole set about Computing Science Discoveries 21-22. If you go to the unit, it then takes you through all the different processes, and again making that link with meta skills that we're trying to embed across the curriculum at every stage for our learners. Also linked there are these resources, and you can go here. We'll put the links in the chat for you at the end. So building real world applications using Python. So again, depending on the languages that you're covering with your classes, you may be interested in those. And then Minecraft as well. So Minecraft has a huge range of subject kits that are available to you. Minecraft's not currently available in Globe, but some local authorities do have access to it. But so this may be something that you want to have a look at. But there's a huge range promoting discussion, learning new skills. There's a whole section on computing science, and they come with full units of work. Again, you can take a look through. You can also filter by age and stage. So I would definitely recommend that if you've not already seen those. So that's just looking at the exploring it. Once you've explored it, you want to practice. So if we look at the practice unit area, I really like this unit. It comes with a whole range of suggested activities. And again, building on what Jacqueline was speaking about, that creativity, the physical computing. So again, we may have started with some physical computing resources, and lots of us have those microbits, makey, lots of different resources are available. But the MakeCode microbit unit, if we were to click that, it takes you through a whole unit. It links with a user who is talking about having a visual display for someone who is hearing impaired. It explains why the young person is speaking about it, and then it shows you all of the resources that you might need. So again, this is a pick up play activity. This is a resource that benefits the technologies easy knows around computing science. It shows you all of the resources, but learners could be doing this independently. And although the example here addresses diversity and inclusion, I've also been in a classroom where S1s and S1 or S2 pupils were using a similar type activity, and it was to solve a problem, and it was a whole sort of unit that they were doing where they to use the microbit creatively. So we had like alarm doorbells, there was all sorts of things that were going on with that classroom teacher, the computing science teacher in that classroom. It was fantastic. So although these units are there, and I absolutely love the projects that are in them, you can apply what's there into different contexts, your learners' interests. There's the MakeCode arcade, again, that was just spoken about, and we've looked at Minecraft. So further down here, again, we have some ideas about where you want the young people to, it gives you an activity that they can carry out. And then again, it's got that similar format where it looks at foundation, intermediate, and advanced. If you're not aware of MakeCode Arcade, hopefully you are, but if you're not, this is what it looks like. You can create things without logging in, but if you log in with your Glow account, it will allow you to save your project within it. You can save it off of the platform and then import it, but if you log in, you'll see your Glow account logs in for you. There's a whole range of tutorials along the top that your young people can work through with you or independently, depending on that. And there's skills maps. The skills maps are fantastic. I really like these. There's even one, it was not long ago, Earth Day, and there's a really nice one around environmental, so you have to get the water tanker to the fire in the forest and things like that. So again, promoting, having that discussion around interdepartmental discussions. So maybe they code the problem, but actually in CDT they design a solution to it, and in art and design they can maybe come up with concepts, and a whole lot of different links can be made around it. And again, referring always back to that curriculum document that's available to you. So in Make Code, you would basically go through, and I don't want to do it a disservice, so I'm not going to do it too much. But for those of you who aren't familiar, in Make Code Arcade, it takes you through step by step. So you can see I just quickly did this one before we started so that you could see block-based coding. So again, if you've got transitional project work going on, maybe your young people are coming from a primary where they've been using a product, for example, Scratch, they could move into this with you. And I really love the digital sandbox aspect of it, where they can then use the arcade. So you can see my sprite is a little block there, but they can see it working live based on what they've done. And the tutorial that I'm in takes me through step by step. So I'm building up my activity and I'm seeing how it works. So I'm doing an activity there to build my skills, but I can then transfer them and design my own game afterwards. So if you haven't seen that resource, I would absolutely check that out. So within the practice code learner slides, again, there's lots of different talking points that are available in here for you to use as prompts with your learners, and that's building back on the work that's there. And there's lots of offshoots that you could be doing, and the physical computing side of things really comes into its own with this unit. The apply section, if I just go back to one of my many other tabs, the apply section here is looking at a range of different options that you can then sort of extend and apply your learners' computer science knowledge. Some of you may have already been using. If you haven't seen the Imagine Junior Cup, I would recommend taking a look at that. I think it's here, yeah. So here you are given a challenge. It runs, it's passed for this year. It happens in February to May usually. So term 2 and 3, no, that's not right, term 3 and 4. However, look out for this. You can also register for information as soon as it comes available. All the information that you would need to take part is there. And the other option that you may or may not have seen is the Learn, so Microsoft Learn here. You can go on, there's a whole range of information, courses, tutorials that you can take part in. There's coding samples, which is really useful. Again, if you've got senior pupils and you want to let them see different ways. It's also a nice way if you've maybe had people coming in and visiting and talking about the products that they maybe use that your learners haven't seen yet. They can see some of the code samples that are there and how that's been used in a different way, or how that's been used from the industry that they've been speaking about. So those are the core principles around Discover Futures coding. I'm sure that you'll agree Jacqueline's input was really inspirational. Hopefully you can then see how that would link into these, and we hope that you could use this recording, share Jacqueline's presentation with your young people. We really want them to be inspired, and these resources complement that really nicely. Some other resources that you may want to check out, if I just present this quickly. So I am part of DigiLearn Scott's team. Oops. Oh, my computer's on a go slow. There we go. So I'm part of DigiLearn Scott's team. We have a site specifically around computing resources. There's a huge range of microbit resources and links in there as well. Also, we have webinars coming up around mindfulness using microbits as well. But also you can go to Tablet Academy Scotland, and we've shown lots of the Microsoft resources as well. So I am going to stop sharing my screen and I'm going to see if we have any questions for myself or Jacqueline. Nope, not at the moment. That just leaves me to say a huge thank you to Jacqueline. Thank you to Niall for Tablet Academy Scotland, and Lara from Microsoft, who are also on the call here today. If anybody does have any questions, please do pop them in the chat. we will be happy to get back to you. We're finishing a little early, but if anybody has any questions, please do pop them in. We'd be really happy to help. Thank you so much for coming along today, and enjoy your evening. Thank you.